Moving on to question 5 now, we have a question here dealing with complex numbers. So a few different parts of this question, so let's jump straight into part A. So part A gives us a bit of information. We're given a few complex numbers here, Z1, Z2 and Z3, and these are plotted in this argon diagram above. And part A just asks us to explain why Z1, Z2 and Z3 can all be the roots of a quartic polynomial equation with real coefficients, okay? So 2 marks for this. So for part A, well, the key thing to understand for complex numbers, and especially complex roots in this case here, because that's what we're dealing with, the key point is that complex roots of a polynomial, so complex roots of a polynomial, you've got to remember these occur in conjugate pairs, right? So complex roots of a polynomial occur in pairs, or they are in pairs, right? So the issue is here now, if you've got Z1, Z2 and Z3, well, we've got the complex conjugate here of Z2, and then we'll have Z3. So the issue is here now, we've got Z2, the conjugate of Z2, conjugate of Z3, and we've got Z1, Z2 and Z3. So the issue is we've got 5 roots there, but remember a quartic polynomial, so a quartic polynomial only has at most 4 roots. So the issue is we've got too many roots, so therefore these can't be all the roots of a quartic polynomial. We'd have too many roots, okay? So too many roots. Okay, so that's just the idea there. We've got too many roots for part A. For part B, we've got a little bit here. So what I'm going to do, I'm just going to clear part A just to make sure I've got enough room for part B. So we've got to show that the argument of Z2 minus Z1 over Z3 minus Z1 is equal to pi over 4. Okay, so let's work these out individually. So Z2 minus Z1. Okay, so our Z2 is up here, that's minus 1 plus 2i. So minus 1 plus 2i minus Z1, which is minus 2, so that's plus 2. This is all over. So if I do underneath now, Z3 minus Z1, and what I'll do is I'll just simplify these in a second. So that will be equal to Z3 minus Z1, so that's going to be, where's Z3? 1 plus I, so 1 plus I. And again, we're taking off Z1, so that's minus minus 2, which is the same as plus 2. Okay, so now my numerator will simplify to 1 plus 2, so that's minus 1 plus 2, so that's 1 plus 2i. Just be careful you don't miss your own negative sign like I just nearly did. And on the denominator, I've got 1 plus 2, so that's 3 plus I. So that's 3 plus I. Okay, so now we just got to find the argument of this. Okay, so find the argument of this. Well, what I need to do first though is deal with this denominator. Okay, so to deal with this denominator, we need to multiply by the conjugate, so that would be 3 minus I. So remember, it's the opposite sign here, so times 3 by 3 minus I. Do the same with the denominator, 3 minus I. Okay, so if we do that over here, and again I'll have 3 plus I in the denominator, multiplied by 3 minus I. 1 times 3, that's 3. I'll have minus I here, plus 6i, so 6i minus I, that'll give me positive 5i. And then minus 2i squared, minus 2i squared. Remember, we'll deal with the I squared in a second. Let's just deal with the denominator first. 3 times 3 is 9. Now remember, this is the difference of 2 squares, so you can jump straight away to doing 3 times 3, so that's 9, and then I times minus I to give you minus I squared. The other 2 terms will cancel, so I get 9 minus I squared. And remember, I squared is equal to minus 1. Okay, so minus 2 lots of minus 1, that's going to be plus 2. So my numerator now, in this case, that's going to be 3 plus 2 plus 5i, so I'm going to get 5 plus 5i on the numerator. My denominator will be 9 minus minus 1, so that's 9 plus 1, giving me 10. Okay, so simplifying this now, I'm going to get a half plus a half I. Okay, so now we've just got to find the argument of this. Okay, so we've got it into its best form to work with now. Now we've just got to find the argument. So to do that, well, that would be we have to do the inverse of tan, so arctan, or tan inverse. Because they're both a half, it'll be half divided by half, like that. Well, a half divided by a half, that would be the same as arctan of 1. And remember, arctan of 1, and because we're in radians here clearly, because this is pi over 4, well, this is just going to be arctan of 1, which, if you do it on your calculator, or if you just know it by memory, that'll be pi over 4. So there we go. So we've shown that the argument here of z2 minus z1 over z3 minus z1 is pi over 4. So that's part B. Part C is just a little bit of a follow-up from that. It says, hence show that arctan of 2 minus arctan of a third is equal to pi over 4. So, remember, when you're dealing with arguments, you can split them up here. So, treating this separately now, this would be the same as the argument of z2 minus z1 minus the argument of z3 minus z1. Okay, but remember, we said z2 minus z1, that's 1 plus 2i. So this is the same as the argument of 1 plus 2i minus the argument z3 minus z1. We said that was 3 plus i. 3 plus i. Well, taking the inverse tan now of both of these, so that'd be arctan. That'll clearly be 2 over 1, so that'll just be 2, so arctan of 2, minus the argument, so this would be, to get the actual argument, you take the inverse of tan, so arctan again of 1 over 3 in this case, so 1 over 3, and notice this gives us exactly what we've got here, and this is just what we've done already, so this is pi over 4. Okay, so that's just a little follow-up from part B there, just showing it in that case. And then finally for part D, we've got a copy of figure 1 here, labelled on diagram 1. Now, the diagram 1 is just the exact same as this Argand diagram here, so I will just do it on figure 1. We've got a shade, the set of points of the complex plane that satisfy this inequality here. So, the modulus of z plus 2 being less than or equal to the modulus of z minus 1 minus I for 2 marks. So, where do we begin with like a question like this? Well, what I'm going to think about first is these 2 points, right? So I've got z plus 2 less than or equal to z minus 1 minus I. Well, let's get this in the form that we work with. So this now, this will be z minus, to get plus 2 that must be minus 2. Okay, so that's the left hand side of the inequality. It's going to be less than or equal to, I've got z, so if we write that down, I've got z, I'm going to do minus again, we always do minus, and to get minus 1, that must be 1 here. Minus, so that'd be minus of a positive, so that gives me the minus 1, and then same here I must have positive I. So now, these are my 2 points that I'm dealing with. I've got minus 2, and notice minus 2 is my z1 here, so we've got this point here, and I've also got 1 plus I, which notice is z3. So we're going to have these 2 points involved in this question. So now, what I've got to consider here is that if I join these points up, so that was a really bad line, let me just undo that. So I'll try again if I can join them up. So z1 to z3. What I need here is the perpendicular bisector of this z1 to z3. Okay, so the first thing I can do is work out the midpoint, and then I can also work out the gradient. Okay, and we can combine them to work out the equation of the perpendicular bisector, and then we just need to shade from the perpendicular bisector. So if we work out the midpoint, so if I just call it MP, so for the midpoint, well, that'll just be the average of z1 and z3. So if I add z1 and z3 together, that's going to be minus 2 plus 1 plus I. Okay, well, doing that, that's just going to give me minus 1 plus I. And then we have to divide this by 2. Remember, it's the average of it. So if I divide it by 2 here, do the same here, that's going to give me minus a half plus I over 2. Okay, so that's the average there. So that's my midpoint, so that's roughly going to be, I don't know, about there, let's just say. Okay, and now we can work out the gradient. So the gradient, well, that's going to be the gradient formula, so that's going to be y2 minus y1 over x2 minus x1. So I'm going to do z3, so that'll be my 1 coordinate there, because it's 1 unit up, plus I. That's going to be 1 minus 0 because that has just no height, it's just minus 2 along on the x-axis, so that's a 0. So 1 minus 0 over, and that's going to be 1 minus 2. So that's going to give me 1 over 3. But remember, we need the perpendicular gradient here, so we take the negative reciprocal. Okay, so my perpendicular gradient is going to be equal to minus 3. So now we've got a gradient, we've got the midpoint here. Now I can just use the formula for the equation of a straight line to obtain the equation of the perpendicular bisector. So if I just do that up here, so remember the formula is just y minus y1 is equal to m lots of x minus x1. Well, plugging all this in now, so y minus y1, so my y1 is a half basically, I over 2, we'll just call it a half, so it's going to be y minus a half, that's going to be equal to minus 3, our gradient is minus 3, x minus x1, which would be minus a half, so that'll be plus a half. Okay, so that's that. Now we just simplify all this, so I've got y minus a half still, minus 3x minus 3 over 2. I'm being attacked by my cat currently. So if I carry on this now before I get attacked fully, minus a half, so I take that across to the other side, so that's going to be y equals minus 3x, and then I've got minus 3 over 2 plus a half, so that'd be minus 2 over 2 or minus 1. So y equals minus 3x minus 1. So it's currently jumping on my back. So y equals minus 3x minus 1. So that's my equation now. So if we just plot that, well, it's going to cut through here at minus 1. So it's going to cut through somewhere there. And if we join this up now, what you'll actually notice is that it goes through Z2. So my cat's jumping over everything. Right, okay. So it's going to cut through here. Let me just undo that, that's not very good. It's going to cut through roughly like that. Okay, it does actually cut through Z2. So now we've just got to deduct where it cuts through, or where it's closer, because it's saying where is it Z plus 2 less than or equal to the distance of Z minus 1 minus I. Well, remember this Z plus 2 is this point here, your Z1, and this Z minus 1 minus I, that's this point here. So which side gets me closer to Z1? Well, that's clearly going to be anything here. If I pick this point here, I'm closer to Z1 on this side here than I am on this side. So we're going to have to shade everything across here. Okay, so what I'm going to just quickly do is I'm just going to rub out this little line here, just so you can see it, and then I'm going to shade it all. So if I shade it all now, what you need is everything to the left of this line. And there you have it. So that's part D. So that's just everything that you need to shade. Okay, so that's your line, and that's your shaded area. And there we go, that's question 5 fully complete.